Part 2.
We're back, yay!
Forces are being drawn with our free body diagrams, our FBD again.
So we're going to practice. Have this. Ooh, okay, got that? We're going to practice with these two examples right here.
So, in other words, we'd like you, when we draw them up here, we'd like you to draw them right there on
You're
your
going to want these examples
handout.
in your book, okay?
So, number 1 example
Number 1,
says,
draw a free body diagram of a cube that weighs 10 newtons and is sitting on a table.
so here is our, remember our free body means there's nothing attached to here, so we are just going to use the square on there, even though it says it's a cube. We don't draw a cube.
No,
we're going to
always
put
use
our
the square.
center on there. And then we have to think about all those forces
Yes, there's a
that
bunch of
are
them.
acting on it. So I'm going to list them all out again. We got gravity. And in case you haven't written these down, you might want to do that.
But you probably have already. But
Yeah. Normal, applied, and friction.
do you want to do like air resistant, like drag? Was that one?
Yeah, and that's what this
Yes.
drag. If it's air. Okay. So it's just sitting there. So what forces are acting on it?
Yes.
I know there's gravity that's going to
Yes.
pull on it. So I'm going to have an arrow that represents the mass being pulled on by gravity. So how much mass? According to this, it says 10 newtons.
10 newtons.
So I can label this 10 newtons, and I'm going to put gravity here.
Yep. Or you could do like the F and the G
Yep.
if you want to shorthand it instead of right now.
And put 10 newtons.
Yep.
Either way, we were communicating the same thing.
Yes. Yep.
Okay, so if that was the only force acting on this block, it wouldn't be just sitting there. It would be moving down.
Yes.
Because that's not balanced.
Right. Remember we talked about balanced and unbalanced forces already.
So I need another force, since it's just sitting there, I need an equal force that's pushing back up on there, and that's going to come from that table. So the table itself is going to not push back up, but it's what we call a normal force here. So an F and an N, and that's got to be equal, but opposite of gravity. So we're going to put that as 10 newtons.
Yep.
There's my free body diagram that shows these are balanced forces. This cube is not moving, it's just sitting on the table there.
And look at how Mrs. Henning labeled every arrow. It's not just random arrows. Her arrows are about the same size.
Yep.
They have the newtons on there. It's perfect.
Yep. Okay, so now that's example number 1. Let's do example number 2.
Okay, right here, this one. So draw this too. We're going to draw a free body diagram of a box being accelerated to the right as somebody pushes on it. So I'm pushing a box to the right. Okay?
Okay, so here's the tricky part. A lot of us want to go, well, if I'm pushing to the right, I want to put my arrow over here, but remember the arrow's got to come out of the center here, and it's going to go in the direction of the right.
Yep.
So even though I'm pushing, my arrow is still going to come out of here, out of the center, and it's pretty big because I am changing. I'm not balanced.
No, I am accelerating. That's your key word there. So I'm moving faster to the right.
To the right. So I have to have my largest force that is showing that acceleration there. Okay? Now, I could do this, but I could say, well, that's unbalanced and it's more forces to the right, but I don't have all of my forces acting on this represented.
No, you got to have them all represented.
So if I'm pushing to the right, is it a box or a book?
It is a box.
A box. So I know I'm going to have some friction. Whoops, I forgot to label this. This is my applied force.
Yep.
And I can make up some
It
big,
doesn't, yeah. If it doesn't give you a number,
I like 100. It's
Yeah.
just nice, easy.
you can make up a number.
Yeah. Okay, so 100 newtons, and then I know that there is an opposing force of friction. So I'm going to put an FF here, and I again make up some small, tiny, it's not going to be very big.
No, because you are accelerating to the right,
Yeah.
so it's that friction's not slowing you down too much.
Yeah, notice my N for newtons here, because that's what we label forces in.
Yep.
We didn't really say that. Now, This, again, is unbalanced, but it does not represent, again, all the forces.
Oh,
We still have gravity acting on this, and we still have a normal force that's pushing back up from whatever it is. So, and again, does it say that?
it doesn't say.
So I'm just gonna use the 10 from our example before, 10 newtons. Okay, there are all the forces. That's my free body diagram for pushing a box and accelerating it to the right.
Yes.
Not balanced. I have, if I wanted to, I could add these two up, so that would be 100 minus 5 equals 95 newtons to the right. How did I do that? Well, because these are going in opposite directions, I'm gonna subtract them.
Yes.
I don't know if that,
I
yeah.
think they already did that.
Yeah.
Yep.
Up there? Says
If
that
you
at the
forget
top.
that, look up there at the top. It's a reminder for you.
Okay, so the same thing, when I have my gravity and my normal, I'm gonna do 10 minus 10, so I have 0 newtons, which means that that's not moving up or down, it's just staying right in that spot.
Yep.
Okay,
Perfect.
that's it.